All right, so we're going to start by looking at this function here. We're saying, oh, let's find the inverse. Okay, so we go y equals x squared. We switch the x and y. And then we want to solve for y. So you're like, oh, I'll take the square root of both sides. It's kind of like that cubed root thing, right? Like we're just saying, take the square root of this side, square root of this side. But what did we have to do? We had to put in the plus or minus. So we're saying something new here. We're saying y equals plus or minus the square root of x. Well, that's a problem because this is not a function, okay? Not a function. We've talked about that before, but this is not a function because for every x value, I'm getting out two different y values, except 0, because I get the plus case and the minus case, okay? So you put in a 4 for x, and you're getting out a 2, but if you put in 4, you're also getting out a negative 2. And so this is not a function, okay? And that's a problem when we're talking about a function and the inverse function, because now I have an inverse, but it's not a function. So there's ways to take care of that with restrictions, but this is the situation there. Okay, first we have to be able to identify it a little bit more. Okay, let me go back, sorry. Let me go back to a graph of what's happening for the original function here. So the original function's saying, I have 1, 1, and then 2, 4. So it looks something like this. It's a parabola. It's one of our common functions. Okay, so that's what it looks like, right? Okay, so this is not 1-to-1, okay? So there's a picture of it. Now I have to tell you what a 1-to-1 function means. So a 1-to-1 function, let's say you have a mapping and you have 1 and 2, and over here you have 3 and 4. And say 1 maps to 3 and 2 maps to 4. That's a 1-to-1 function. Each input is going to one output. But let's say you have 1, 2, and over here you just have 3. You have 1 going to 3, and you have 2 going to 3. That's a function, but it's not 1-to-1, because you have 2 different inputs going to the same output, okay? So this is not 1-to-1, and they'll write 1-to-1 sometimes like that as a little abbreviation. This is 1-to-1. So counting is 1-to-1, right? Like you count how many, sheep you have or something. You're a sheep herder. And so you say, okay, there's 1, 2, 3, right? Or like when you were little in preschool and they said, oh, let's count the ducks. Pretend like those are ducks. So you say 1, 2, 3. And you establish this 1-to-1 relationship where each duck gets a particular number. That's counting, right? Okay, so that's what we mean by 1-to-1. Each input is going to one output, okay? And each output receives one input. Okay. Another way to see if something is 1-to-1 is to check to see if it passes what we call the horizontal line test. So the vertical line test, like when we had a function, this was our common function, right? And we said, oh, it's a function because it passes the vertical line test. Well, if it passes the horizontal line test, then it's a 1-to-1 function. Okay, well, if it's a function. Okay, so first you check to see if it's a function. It passes the vertical line test. Now, on my diagram over here, if I can pass a line and it only hits one place, a horizontal line, then it's 1-to-1. Okay, so this is not a 1-to-1 function. Okay, the parabola. Now, what if I said, well, I don't want the whole parabola. I only want like half a parabola. So maybe I just want this piece. Okay, is it a function? Yes, it passes the vertical line test. So yes, a function. Now, is it 1-to-1? Yes, it's 1-to-1 because it passes the horizontal line test. Okay, so vertical line test goes this way and it passes. So yes, it's a function. Horizontal line test goes this way and it only hits in one place. So yes, it's 1-to-1. Okay, so vertical line test tells you if something's a function. Horizontal line test tells you if it's 1-to-1. Okay.